In this lesson, we're going to be solving this problem. This problem is under hollow shaft. The problem statement, it reads as follows. A hollow shaft transmits 3 megawatts at 150 revolution per minute. The shear stress is 60 megapascal and the angle of the twist is 2 degrees. The external diameter is 300 millimeters and the length is 500 millimeters, and we've got the modulus of rigidity, which is 80 gigapascal. Here we are required to calculate the internal diameter. As here we'll see on the picture here, the hollow shaft, it's something like this. Let's change here, it's supposed to be O. The hollow shaft is something like this. You see on the picture, there's an outside diameter here. Outside diameter, which is from here up to here. That's the outside diameter. Then we've got the inside diameter. It is an internal diameter. It's here, the internal diameter. It's here. It's from this part, goes like this, or maybe draw like this, the internal diameter, like this. That's how it goes. Outside, it is a external diameter. This one's an external diameter. This one is a internal diameter. Say maybe here, small d. This one, it's a bigger d. It goes like this. The outside, external. Inside, internal diameter. Because on the problem, they are looking for the internal diameter, whereby we are given the external diameter. Yeah, we are given the external diameter. So here we have the rotational speed. That is 150 revolution per minute. Then we've got the shear stress, which is 60 megapascal, which is 60 times 10 to exponent 6 pascals. Then we've got the external diameter. We will represent it by a capital letter D, the external diameter, which is 300 millimeters. Then this is 0.3. Then we've got the angle of a twist. It is angle of a twist, it is 2 degrees. Then you convert it, it's gonna be 2 degrees. You convert it into radians. Convert it 2 degrees divided by 57.3. Convert it like this. Then what we have, we've got the length here. The length is 500, which is 500 millimeters. Then this 500 millimeters is 0.5 meter. Then we've got the power. The power, it is 3 megawatts, which is 3 times 10 to exponent 6 watts, like this. Then we've got modular of rigidity, which is, it's 80 say times 10 to exponent 9 pascal. That's a module of rigidity. Then we're required to find the internal diameter. We'll represent it by the small letter d. Tokyo formula, it is Tokyo is equal to a pi divided by 16 shear stress, then external diameter to the power 4 minus internal diameter to the power 4, all divided by external diameter, like this. We're looking for this internal diameter. So, but before to find this internal diameter here, you know that there is a lot of unknown in this equation. This internal diameter, it's unknown, and also this Tokyo we don't have here in the given data from this problem. So we must first find this Tokyo. So it's gonna be easy when we come to this formula to plug every information that we have in order to find this internal diameter. So the formula that we're gonna use to find the Tokyo, we're gonna use the power formula, because here we've got the power. Let us write that power formula. It is P is equal to 2 pi, then the rotational speed, then the Tokyo that we're looking for, all divided by 60. Let's move a little bit up. Here we've got the power, we've got the rotational speed. The only unknown is a torque. That means we can find the torque here. So we make the torque a subject of the formula. The torque, it is equal to P times 60 divided by 2 pi rotational frequency. Here the power, here it is 3 times 10 to exponent 6, like this, then times 60, then divide by 2 times pi times the rotational speed. It is 150. It is 150. Don't worry about the conversion. This 60, it's gonna convert this 150 to be revolution per second. That's why this 60 is here, is to convert that revolution per minute to a revolution per second. So here when we proceed, we get the answer to be 190.9 times 10 to exponent 3. Because it's a Tokyo, it is a newtons times meter. It is like this. Because now we have found this Tokyo, we must go back to the Tokyo formula, this one, because our goal is to find this internal diameter. Then we have to go back to this equation, the Tokyo equation. Then the Tokyo equation is equal to Tokyo is equal to pi divided by 16 times the shear stress, the external diameter to the power 4 minus the internal diameter to the power 4, all divided by the external diameter. We have the Tokyo. It is 190.9 times 10 to exponent 3 is equal to a pi divided by a 16 times the Tokyo. The Tokyo that we have is 60 times 10 to exponent 6. Then we have the external diameter to be 0.3 to the power 4. Then we don't have the internal diameter to the power 4. We have the external diameter 0.3. It is like this. When you are looking at this formula, as we have plugged all the information here, all the data that is given by this statement problem here, we've got only this unknown on this. That means it's easy to solve it, just to use a mathematic here to make this a subject of the formula. D is equal to 237.84 millimeters. That's the answer for internal diameter.